Today's question comes from the 2024 Paper 1 higher tier, and it's all about ionic compounds and also electrolysis, a topic which I know many of you find really difficult. Calcium chloride is an ionic compound. Now we know that anyway, just purely because calcium is a metal and chlorine is a non-metal. Now what does that mean? Metals have slightly too many electrons, so they tend to lose them, whereas non-metals have slightly too few and they want to gain electrons. Remember, atoms try and have a full outer shell, and when I have a metal and a non-metal, they do this with ionic bonding, and that is all to do with swapping electrons. So it says here, calcium and chlorine react to produce calcium chloride. Describe what happens to calcium atoms and chlorine atoms when the ionic compound calcium chloride is formed. So we also know this is a describe question, so that means we need to say what happens rather than why. If I look at calcium, calcium is in group 2 of the periodic table. And what that means is it has 2 electrons in its outer shell. So this wants to lose 2. If I look at chlorine, chlorine is in group 7 of the periodic table. It's a halogen. So that means it's got 7 electrons in its outer shell and wants to gain 1. And that's what happens. Calcium loses 2 electrons to form positive Ca2+ ions. Chlorine gains an electron to form negative Cl- ions. Now, one thing which is a little bit interesting here is the fact that calcium loses 2 and chlorine gains 1. That doesn't mash up. Where are those electrons going to come from? Well, we have to remember that reactions happen in bulk. Not just one atom reacting with one other atom, we've got loads of atoms around there. So all we need to do is to realise that if the calcium needs to lose 2, we need to have 2 chlorine atoms, each to pick up 1 and make that happen. So the last thing just to add is simply that 2 chlorine atoms react with 1 calcium atom. Next question talks about solid calcium chloride and why it cannot be electrolyzed. Now, for electrolysis to happen, we need to have ions that can move. And there's 2 situations where this happens, where it is in solution or where it's molten, where it's melted. However, solid calcium chloride has this rigid lattice structure where the ions are not going to be able to move. So it's simply the ions cannot move to carry the charge. Now, aqueous electrolysis is arguably the hardest subject in the chemistry GCSE. So it says, name the product formed at the negative electrode when aqueous calcium chloride solution is electrolyzed. So we need to think first of all about what ions we've got present. Well, from the calcium chloride, we've got Ca2+ and Cl-. But because it's aqueous and it's dissolved in water, we also have H+ and OH-, which I suppose you can think of as oxygen in disguise. So we now need to decide which one is going to be made. Well, first of all, we're at the negative electrode, so that means we've got to be looking at one of those positive ions. And the rule tends to be, at the positive electrode, we have something called the electrochemical series, which determines exactly what is made. But the nice rough rule of thumb is that the least reactive thing is made. So given the fact that calcium is more reactive than hydrogen, hydrogen is made at the negative electrode. The next question deals with the positive electrode. So we're now looking at this side. Now the rough rule of thumb here is that if there's a halide, chlorine, bromine, iodine, we tend to prefer making the halide. If not, we then tend to go for oxygen being made. But because we've got chlorine here, that means we've got this halide. So that means we're going to be forming chlorine. So we can straight away discount these two. So because we're starting with the ions and we are reforming our molecule, these two here, these two chloride atoms are going to lose their electron, which means that they are oxidized. Oxidation is loss of electrons, and therefore this is what occurs. The last bit of this question talks about electrolyzing green copper chromate solution. So we can see we've got a power supply with our green copper chromate solution here and our electrodes, and when they turn it on we get a blue colour and a yellow colour. So the question says copper chromate solution contains Cu2 plus and CrO4 2-, and it says explain. So we know, just like the Backstreet Boys, we need just to tell us why. The results shown here. So why do we get this blue colour and why do we get this yellow colour? The first thing here to think about is our ions. Now we have to learn about our ion recognition, and Cu2 plus is blue in colour. Now we'll notice that we've got a negative ion and a positive ion. Now here, this is suggesting with our negative electrode and our opposites attracting that we're going to have our positive ions are going to move towards the negative electrode and our negative ions are going to move towards the positive electrode. So, putting it all together, we know that Cu2 plus are blue in colour. Because those copper ions are positive, they're going to move towards the negative electrode. So now let's explain the yellow patch. That therefore means that those chromate ions are yellow. And because they're negative, they're going to move towards the positive electrode. Also explains why it's green, because that is essentially blue and yellow added together. So there we have it, our exam question for today, all about electrolysis, a really tricky topic, and also a little bit of ionic bonding revision. See you again soon.